assumptions were made in order to model the Sunrun's last mile installation process. First, the only factors affecting installation times are number of panels, the brightbox requirement, and the crew size. Second, the driving speed between coordinates is assumed constant with a value of 40.17 miles per hour. Third, if an installation is blocked, the crew drives back to the install branch, unloads the equipment, and ends the workday. Fourth, it is assumed Sunrun owns enough vehicles to move at least 8 crews. Finally, a crew that ended its assigned job will not help another crew if the estimated time of arrival to the other site is past 4 p.m. With regard to input data, the most challenging aspects were, first, as the coordinates provided in the data file are not real, it was not logical to fit a distribution. Instead, we decided that each job will be randomly assigned to one of the historical installation sites. This was implemented by using a data table so that the only change that has to be made within the model is to update the table with real coordinates. Second, we observed that the variability of installation times is not entirely explained by number of inverters, number of panels, and the brightbox requirement. In fact, we found out that there's another factor affecting installation times. We assumed that this factor is the number of workers that were assigned to each of the jobs. From now on, we will refer to this factor as crew size. A second assumption made was that a bigger crew size will represent a smaller installation time. With this in mind, in order to estimate the crew size of each of the installation times, we followed the next procedure. First, we grouped all installations that had the same number of panels, inverters, and brightbox requirement. Then, with the created groups, we developed an algorithm capable of recognizing which installations had approximately the same crew size. This was done by relying on a k-means algorithm explained in detail in the appendix. Finally, relying on the clusters created by the algorithm, we assign each of the clusters a crew size satisfying the minimum and maximum described in the problem statement. This process was repeated for all the groups. Third, a linear regression was made for calculating the standard installation time. This explanatory model is function of the number of panels, crew size, and brightbox requirement. However, we found that this model did not satisfy some linear regression assumptions, such as homoceasticity. To solve this, we transformed the response variable using one of the Box-Cox transformations considering a lambda of 0.1.